So today we're going to talk about extrema and end behavior. Tomorrow we'll have, are we good? I still hear a lot of voices, guys. I'm going to wait for you. Okay, so tomorrow we'll have weirder notation, but today's notation should actually be really familiar to you because we're going to start by talking about extrema. And if you can guess, extrema is like the highs and the lows, which in math we call our minimums and maximums. So graphs of functions can have high and low points where they reach a maximum or minimum value. The maximum and minimum values of a function are called extrema. So these are called extrema. I normally just call them by whatever they are. So the maximum, which I'll do in blue, the maximum is at the highest point on the graph of a function. We are going to see some weird things where we have an arrow upwards, so we consider that not having a maximum because that goes on forever. Likewise, the minimum is at the lowest point on the graph of a function. Okay, so if you have one of those graphs where the arrow goes up forever, obviously you don't have a maximum, but you still might have a bump where it looks like it's like a high spot. That has a name as well. That's called a relative maximum. So a relative maximum is located at a point on the graph of a function where no other nearby points have a greater y coordinate. So it looks like a little bump on the mountain as you go up. We'll see lots of examples. So if we have relative maximums, we must have relative minimums. So a relative minimum. A relative minimum is located at a point on the graph of a function where no other nearby points have a lesser y coordinate. So these will be little dips. So you won't always have all four of these. In fact, I don't think it's possible to have all four of these. At most, I think you can have three. You can either have a maximum, a relative maximum, a relative minimum, or some combination thereof. So let's see some of these. So example one is just to find extrema from graphs. So we're going to identify and estimate the x and y values of the extrema. Round to the nearest tenth if necessary. I spent today going through tomorrow's homework because last year it was tons of decimals. Do you remember that? All the decimals. That one day with the guessing, I fixed it. I had to draw the graphs by hand. So we won't have to estimate. We're using whole numbers here. It looks nice. But in general, you can estimate these. So if you look at this graph, let's think about our maximums here. We have arrows pointing up. So what are they going towards? Infinity. Infinity can't be a maximum. I mean, it's true that it goes to infinity, but we don't call that a maximum. So this graph does not have a maximum. It does have a minimum. It's not a relative minimum, it's the actual minimum. So we do have a minimum. And it's not relative because it is the absolute lowest that blue line goes. So our minimum here is at 0, -5. So you'll see on your homework assignment today, I have 4 spots. I have a spot for maximum, minimum, relative minimum. If it doesn't have one of those things, you just type in none. If it has multiple of like the relative ones, you just separate them with a comma. Part B, we have our graph g of x. So again, as you look for a maximum, we have a blue arrow pointing up. What does that mean we go to? Infinity. So we don't have a maximum, but we do have a relative maximum. See this bump right here? That would be a relative max. No, abbreviate maximum is just max. So that coordinate point, being careful to read my little tick marks here. This is at -2, 8. Now, same thing as I look for a minimum, I see an arrow here that's pointing down. So that means I'm going down forever, which would mean I'm going to negative infinity. So there's no minimum. However, I again have a little dip. So my relative minimum, are we good? I still hear lots of conversation. Our relative minimum is at 0, 4. All right, what do we think about identifying these from a graph? This is a majority of your homework, so we're going to breeze through today, especially since I can't get Blooket working. All right, I'm going to do one more example. All right, example 2. This is a problem with context. I do not know when this data was collected, but it's interesting. So example 2, it says, use the table and graph to estimate the extrema of the function that relates the number of hours since midnight, which is our x, to the number of posts being uploaded, which is our y. We're going to describe the meaning of the extrema in the context of the situation. So just again as a reminder, yesterday we talked about x and y intercepts. Notice here we do have a y-intercept. So this y-intercept, if we thought about what it represents, that's our starting point, right? Right at midnight. So we can say at midnight, because that's what our 0 is. At midnight, there were 2.8 posts. Now, I'm going to say 2.8 posts, but if you look at our y-axis, it's number of posts, and then what's the unit there? Hundreds, thousands, right? So there's not 0.8 of a post. There's not 2.8 posts. There's 2.800,000 posts. But I don't want to write that out. Okay, so this is actually just asking us about our extrema. So let's go through and look for our maximums and minimums. So I'm going to start with our maximum. Our maximum. I do see an actual maximum right up there. This we don't really have to estimate because we can look on that table next to it. So our maximum is at 12, 11.5. But what does that actually mean in context of this situation? Well, what this means is that there were 11.5, and again, hundreds of thousands of posts at, now this is at noon because 12 hours after midnight would be noon. I think I can fit that over there. I can. At noon. So there were 11,500,000 posts at noon, which makes sense. That's like the lunch hour, right? So I guess I would expect lots of people to be posting at lunch. All right, so after our maximum, let's look for our relative maximum. We do have a relative max right here. So that coordinate point is at 16, 10, and I actually think it's 10.2. 16, 10.2, and I got that 0.2 out of the table. But what does it mean? So first of all, 16 hours after midnight, what time is that? 16 hours after midnight. Yeah, it's 4 p.m. So if you're good with military time, I'm terrible with military time, but there it is. So that's at 4 p.m. Let's say there is a spike in posts. There is a spike in posts. Can I fit it? No. Again, this makes sense to me. Like maybe people are getting out of work at 4 p.m. and they want to post about how bad their workday was or how great their workday was. Makes sense.
Is that what you're doing afterwards?
Never. I only post nice things. All right, let's look at our minimum. So I have a minimum here and a minimum here. And this is actually my absolute minimum just because the context of this situation. I know it has an arrow there, but you could assume that this graph would just repeat. Like every day it would do the same thing, right? Because it's not like this one day would be unique. So in theory, it's just going to keep going with this same graph. So let's call that first red mark an actual minimum. Oops, wrong writing utensil, come back. So I have a minimum. And again, I know there's an arrow there, but we're going to take the context of this situation and assume it just does the same little weird loop-de-loop every day. My minimum is at 4, comma, and then I think off the table it was 1.8. It wasn't quite to 2. All right, what time is it 4 hours after midnight? 4 a.m. I think this makes sense that there would be the fewest posts. I used to be a night owl. I did pull a couple all-nighters in college. But in general, even in my night owl esque phase, I was in bed by 3 a.m. I think. So 4 a.m. it would make sense that we're asleep. So at 4 a.m. there are the fewest posts. And again, this makes sense to me. So then the only other minimum we want to think about is that one in between our two, our maximum and our relative maximum. So this is our relative minimum. So our relative minimum happens at 14 hours after midnight with 900,000 posts. So 14 hours after midnight is what time? 2 p.m. So at 2 p.m., I'll just say there is a dip in posts. I guess if I were interpreting this, that would mean it's our most productive time of the day. It's when the least of us are, maybe, well, it's not the least of us because it's still more than that actual minimum, but in terms of working people, maybe that's when we're all working. Okay, so that's putting some meaning behind these extrema. Do you guys have questions about our extrema? I like saying that word. Okay. Then